Hello there, college algebra students. This is Mr. Kashi speaking. In this video, we're going to be going through the notes for our zero chapter, 04, which is on nth root and real exponents. If you get stuck, there's obviously more examples there on page P14, which is that preliminary chapter in our textbook. Feel free to obviously pause the video. I might go a little fast at times, knowing that you have the ability to pause it. So. Just starting off with our first key point and just simplifying radicals. Okay, let a and b be real numbers and let n be a positive integer greater than 1. So here we're talking about exponents, a equals b to the n. And this is just a chart that I wanted to give you here to kind of separate when n is even and when n is odd. Obviously you're going to be getting different results. But just kind of like a real quick review. So if we had like 2 to the third, well, that would be obviously multiplying 2 3 times, but you'd get 8. But the opposite side of that is if we had the third root of 8, you would get 2. Okay, so this is something that you almost have to start memorizing, just kind of like your perfect squares. Sometimes you want to talk about your cubes, your perfect cubes, like 8 and things like that. So with that being said, we'll move on to the next slide here and go through some examples of just how to evaluate. The first one is pretty simple. You should know the square roots here, but there is a negative sign out front, and so we can take the square root of a positive 49, which that's a perfect square. That'll be 7. The negative out front makes that a negative 7. Okay, this b gets ramped up quite a bit, going to a third root. Okay, and what I would do here is I would say, hopefully you remember a property, and we'll actually be reviewing it later. If we can split these up into cube roots of 64 and the cube root of 27. Okay, and if you think about it, we have the cube root of 64. Well, that would be 4 times 4 would be 16 times 4 would be 64. So the cube root of 64 is actually 4. And then 27, 3 times 3 is 9, times 3 is 27. The cube root of 27 is 3. So you have 4 thirds, or you have 1 1/3, or if you want to go 1.3 repeating. And then finally here we have negative 121. So here we have a negative that is, we want to know the root of that, since we have for a couple of things. So 121, hopefully you know, is 11 squared, but 11 doesn't help us out because we're taking the fourth root of this, and we're taking the fourth root of a negative, and that is not possible. Okay, so this doesn't exist, or it's a non-real number. All right, moving on to the next slide here. We have a couple of properties that, these product properties and the quotient property that are going to be helpful. And so this is dealing with radicals. So if you had two separate radicals that had the same root, so here in this case they have n, you can put them under the same radical. Or if they're separated with a quotient, so n to the nth root of a divided by the nth root of b, you could put them all under the same. And remember, with these equal signs, we can go either direction. So if we start on the left, we can manipulate an expression to look like it is on the right, and the same thing for the quotient properties. Over to the right here, I just wanted to kind of review a couple of simple power rules too, with exponents. So if we had something like x to the n times x to the m, we would add those exponents, n plus m. So just real quick example would be like x squared times x to the 5th. That would be x to the 7th because we're adding the 2 and the 5 there. Okay, and then another one would be like if we had parentheses and we're raising that parentheses to the power, that whole power to the power of n raised to the power of m, we would multiply those. So that'd be n times m. So if we were to use those same exponents, x squared, and raise that to the 5th, well, now we're talking that's x to the 10th because we're multiplying those. And then one other one dealing with quotients. So if we had, let's say, x to the n over x to the m, well, we could do that same thing and just subtract the exponents. So another example there, let's maybe go x to the 7th over x to the 5th. Well, that would be x squared because we do 7 minus the 5. Okay, so hopefully that was just kind of a brief, like I said, if you need to rewind and take a look at that again, you can. But those types of properties might help us out here with these ones. So we have, for letter A, we need to simplify the 6th root of 18. So one thing that we could do is hopefully you can kind of see how 18 is divisible by 6. If we have the 6th root here, and I'm going to actually use that power property where we have, we're going to put n to the 3rd and raise that to the 6th power. So hopefully you can see how we kind of divided that 18 into 3 times 9 using this power, using that power property right there. And if we take the 6th root of something that has something raised to the 6th power, basically like right here, basically how I like to think of it is these two things cancel out and all we're left with is n to the 3rd as our simplified or our simplest form in that case. For letter B, we have a little bit more work to do. In this case, I would probably use that product property first, where I would take them and give them each their own. So I'd take the 4th root and of 81 like that, and then I would have the 4th root of a plus 1 to the 12th. Okay, I'll bring it down here to the left. So we could probably do the 4th root of 81 already. That would be 3. So you have 3 times 3, which is 9, times 3, which is 27, times 3 a 4th time, which is 81. So that would be 3. And then the other one has a little bit more work to do. I would do that same strategy as we did in A, where we have the 4th root. And it's going to be kind of confusing just because we have to set up another set of parentheses here. So we have a plus 1. But the main point of this is that we're going to split that 12 up into 3 and 4. And the reason we're doing that is so we can go through and cancel out those 4's, right? And so we would get a final answer of 3 times a plus 1 to the 3rd. All right. And then C should look a little different. The first two kind of worked out really well. C, I would do a little bit different strategy. I would probably break as much of this apart as you can, because hopefully you can see we have a 3 here, and we're taking the square root of something that's to the 3rd power. Well, that's not going to cancel out. So what I'm going to do is I'm going to take the 63 and the y to the 3rd and break it up into its factors. And then I would give each of them their own radical. So here I would have the square root of 9 times the square root of 7. Hopefully you can see how the 63 could be split up into 7 and 9. The reason I do that is because the 9 is a perfect square, so that'll be able to take the square root out. And then I would do y squared times y by itself over there, because the y squared will get canceled out with the square root. So then to simplify that, so the square root of 9 would be 3. The square root of 7 has got to stay. The square root of y squared would just turn to y, and then the square root of y has to stay as well. So here we would have to kind of clean this up a little bit, and I would say that we'd put the 3y out front, and then that 7y would go underneath the radical like that, which would give us our simplest form. All right. I'm running out of time here, so I think that's all we'll do for this video. I will have a second video for this lesson later on.